I'm Ryan Gifford, and this is Gifford Fabrication.
Hi, my name is Ryan Gifford, and welcome back to my workshop. Today I'm going to do something I don't normally do. I'm going to do an unboxing video. Um, I don't know, they're just not really my thing, but this one's pretty cool. About 3-4 months ago, I changed out my dust collection. I added an Oneida Supercell, and it has been phenomenal. It's an absolutely incredible piece of equipment. I couldn't be happier with it. If you're not familiar with it, you can read up on it online, but basically it's, in the most generic sense, it's like 3 shop vacs put together, specifically designed for tools with 4-inch or smaller dust collection ports, which in a small one-person shop with a lot of benchtop tools, that's pretty much what I've got. So previous to that, I was using a rigid shop vac that I had plumbed in with ABS pipe, and it actually did okay. It really did, as long as the orifice is pointed directly at where the dust is being produced, it actually does pretty well. Um, if you're not real familiar with it, shop vac basically works on high pressure, low volume. So there's putting a whole bunch of vacuum draw, a whole bunch of pressure right at the end of the hose, but it doesn't move a whole lot of volume. So in a traditional workshop with large open areas, like think under a big cabinet saw, you're not going to move all that air, so you're going to have a lot of dust that doesn't get collected. However, if you think about a shop vac that you would use, to just clean up around the shop or whatever, if it's right at the end of the hose, it does a really good job drawing in air and drawing in chips. So with smaller dust ports on a more focused area, that shop vac actually does okay. I had blast gates set up the whole 9 yards. I mean, it was like a real dust collection system. It just was small. Um, there were a couple of tools that didn't work well for that. My my thickness planer, my DeWalt 375X, and my Wahuda 8-inch joiner just didn't do well, and that's kind of obvious because there's a little bit bigger space to collect from, even with the 735's blower behind it. But the chips that are coming off of those devices are big. They're big and they're thick, and so a smaller diameter dust collection system just couldn't keep up, and I would clog up um, my ducting, and I have to clean it up, and it was a pain in the butt. So the system was okay, what I was using with the rigid shop vac, but when I went to the Supercell, it is night and day difference. So everything is drafted up. The Supercell provides both high pressure and not as much volume as a traditional large impeller dust collection system, but it provides a fair amount of volume. You can read charts on it and see, but somewhere in the 400, 600 CFM range, which, as long as it's a smaller dust port, again, it's not that big of a deal. So while a shop vac may provide high pressure and low volume, a traditional two-stage or one-stage dust collector with a big impeller, like a lot of folks have, moves high volume, but it moves at a very low pressure. So you're moving a bunch of air. It just can't really pick up big chunks unless that air is being moved very rapidly. And so where that falls down in a small shop is that when you have that nice 4 or 6 inch opening and you're moving that large volume of air, it does a really good job. But if you have to neck it down to 2.5 inches or something like that, the restriction in air movement means that while the machine is trying to move a large volume of air, it just can't. The hole that's moving it through is too small, and therefore you lose a lot of the suction that the machine produces in the first place, and that you get a reduction in CFM as well. So it's pretty tough to take a large dust collector and really neck it down. And if you want to go to the extreme, you try to neck it down to fit on, a palm sander or something. It's just not going to do anything. So the Supercell was kind of designed to bridge that gap. High pressure, fairly high volume for what it is, and it is designed specifically for small shops with, like I said, uh, dust collection ports 4 inches or less. So for me, it's been awesome. I replumbed the shop. You can see behind me the white PVC that everybody uses. It's a sewer and drain pipe, and redid the entire shop with it. And I'll do a video at some point, probably a shop update that shows all that. But believe it or not, that's not what this video is about, even though I've rambled on for 5 minutes with it. No, today I want to do an unboxing of this box right here. This is some automation parts for my dust collecting system. It's from a company called Grit Automation, and a little bit about how I found Grit. I was honestly just, surfing through the internet, probably looking at Facebook woodworking groups or something like that, and I saw an odd post that was actually a reply within a post, and it mentioned Grit Automation as an automated system for blast gate dust collection and dust collection in general. And I'd never heard of Grit. Pretty much the only dust collection automation system that I really was familiar with was IVAC, and I wasn't a fan of the IVAC system. I looked at it; it wasn't going to work for me. I think it's a great system; it does what it's supposed to do. It just wasn't great for me. And my biggest hang up with IVAC, honestly, besides the initial cost, which is there, but everything's powered, so you have to have a whole lot of extra receptacles, a whole lot of plugs to plug all these different pieces into to make all these different pieces work. And I just don't have that. I've added receptacles to the shop, but I'm tapped out. I mean, this is a small shop. It's 440 square feet about, and it's all tapped out, even with a sub panel in it. So, someday when I get a real shop, maybe that's not a problem. But what drew me to the Grit system when I did some research on it, and I will say that when I did research on it online, I didn't find very much. They're a fairly new company, and I just didn't find a lot of information on them. So I kept digging, and I found a couple more pieces. And as I started looking at it, I started realizing that the way that they power their system is unique. Basically, it's taking all the pieces and daisy chaining them together and running them on low voltage. And this works because Grit uses a mesh system to communicate. And what that means is that if you've done any automation in your home, each of the devices for Grit talks not only to each other, but to every other device. And by repeating that message again and again, you ensure that the message actually gets to where it needs to be. And if this is all Greek to you, there'll be more explanation on it. But because it's a mesh system, and because of the hardware and firmware that's necessary to run a mesh system, it all runs low voltage. And because it all runs low voltage, the folks at Grit did a pretty fantabulous job of figuring out how to allow that low voltage to jump by wire, but from device to device to device. So you can take multiple, up to 6 different devices, I believe it is, and tie them together. That means you could daisy chain together just 6 blast gates, or manual switches, or other devices, and it's not the wiring that's connecting them isn't transmitting a signal back and forth telling the gate to do something. It's just providing power. Once the device is powered, then it's able to send and receive messages through this mesh network, and that is what allows the devices to communicate. And so what that means is that a machine trigger that activates doesn't necessarily have to be anywhere near or connected to the blast gate it talks to, or several blast gates it talks to. And that's one of the things that I will show in a future video once I get my system up and running, and want to go back through and kind of talk about why I set it up the way I set it up, and kind of the parts and pieces that drove me to this outcome with these automated blast gates. But that'll be a future video. But it's a unique system. It's unique in that I think it harnesses a lot of the newer technology that's available and puts it into a system that I think fits the culture of woodworking. If that's such a thing, there's people who are pretty old school about their woodworking, and the idea of adding technology is not always well received. So if you're going to add technology to woodworking, it's got to work. It's got to work the first time, and it's got to be efficient and effective. And I think that's what Grit's come up with. So without dragging on too much longer, we'll get to this, what was supposed to be a fairly short video, and do this unboxing. We'll take a look. Okay, so like I said, this is an unboxing, and this will be the first time that I've actually seen the Grit automation pieces in my own hands. So let's open this thing up and see what they sent us. So evidently it comes with candy, which is obviously cool, because who doesn't want candy to start their day off with, right? Nice sticker. Okay, so here are the goodies. So talk a little bit about these as I pull them out. This is a 120 volt machine trigger, and so what this does is it plugs in line. So male end of this plugs into your existing receptacle. The female end then gets the machine plugged into it, so you're not adding a plug anywhere. It's just there like it's supposed to be without taking up any more room. And this machine trigger, when it senses current draw, it sends a signal out through the mesh system that basically, starts a communication with everything else. And here's what I was talking about. This port right here is a power takeoff that allows low voltage to then be pulled out and sent to other devices within the system, just for power, not for communication, but just for power. So this is a 120 volt trigger. There's 220 volt triggers, and they also do 3-phase, I believe, although that's done differently. But they have that available. Let's see. This is an actuator. So we'll open this up. This is a servo-driven actuator, and effectively what it does, this is for a 4-inch blast gate, and this is designed to sit on the side of the blast gate, and then when it's given a signal, it articulates this arm back and forth, and that slides the gate open or closed. It comes with its own hardware specific to mounting to an aluminum blast gate. That's what it's meant for. It's what it's designed for. And there's some videos out there from Grit that show kind of how that works. And once I get my own assembled, I'll show more of that. But this is an LED strip light that's either red or green, telling you if the gate is open or closed, and evidently does disco stuff. I'm told eventually that you'll be able to watch them pulse to music. I've been promised this. I'm told that will occur, so I'm waiting on it. Joel, it sounds like a thing for you to work on. This is another blast gate actuator. This is smaller, and one of the unique things about Grit is that they have designed their actuator. It's the same body, it's the same servo body, but it has a different arm on it. And this arm is for a 2.5-inch blast gate. So in a smaller shop where you don't have all 4-inch blast gates, you can use a smaller blast gate. I'm told these arms are interchangeable, so if you need a different arm, you can move one from one to the other. And once again, it comes with its own hardware to be mounted onto the blast gate itself. So small actuator. This was one of the things that I was really interested in. This is basically a manual switch. So the machine switch senses a change in power running through the machine, and it sends its signal out. This is a manual switch, so I have some take-up hoses in my shop that I use to clean up or whatever, and then I have a couple of non-dedicated areas where the flex hose moves from machine to machine, and so tying a specific machine to the actuator for that blast gate really wouldn't work for me for a couple different reasons, and I'll line that out when I show you the build on the shop. So this is a manual switch that basically turns on and off, but what it does is when it's turned on or off, it sends its own signal out to actuate any of the blast gates you want. So if you want to set up zones within a workshop, say a zone 1, zone 2, zone 3, you could use this as a zone control to actuate and open up a zone without actually having a machine tell it to open up. There's a lot of really cool innovation that went into this piece. It's really neat. So it uses a barrel plug that you might be familiar with to plug into a wall wart if you wish to power it that way. But they also built a little adapter to allow you to pull from any other device, power across, and that just plugs right in to the barrel plug on the bottom of the bracket. And this is a bracket. The switch actually pulls out, is designed to have a rechargeable battery in it so that you could put this on your belt or hang it someplace and have remote actuation. Again, there's a barrel plug right there that this just mounts into. But that also means if you don't want to use this mounting bracket, it's too big or whatever that looks like for you, you could pull this out, take the barrel adapter off, and now you can just run your cable that's providing power directly to the switch, and then mount this under or on whatever you want. And that's actually my plan for it. I'm going to mount a couple of these under tables so that in the center of the shop I can just reach under the table and flick it, and it'll turn on, open specific blast gates and turn on the power to the dust collector as well. So I'm excited about that. This is a really neat piece that I think adds a lot of versatility to the system. Speaking of the dust collector, so far all we've talked about is actuators and machine controls. This is actually the mag switch collector, the mag switch for the dust collector. And this was designed for Laguna style mag switched machines, but what it allows you to do is wire this directly into the dust collector's magnetic power switch. And so when this receives a signal to turn on the dust collector, it just turns on the collector directly. So you're not turning on and off power at the receptacle, which obviously with the dust collector it could be is 220. In a lot of cases, well, you would need a larger capacity switch, a higher amperage switch, whatever that is. What this does is it basically keeps everything low voltage, and it just hijacks the signal that goes on within the mag switch for the dust collector to tell it what to do. So the dust collector still functions entirely on its own. The remote that probably came with your dust collector still turns on and off the dust collector. Everything is still the same, but this switch basically is just parasitic in that it sits there, and when it receives a signal, it tells the machine to turn on, independent from any other switching. So that's a pretty cool innovation as well. This is the hub. Because it is an automation system, obviously there has to be a central hub to receive it, and this is the hub, much bigger than the other devices, but this is the brains of the whole thing. And here's the antenna. Obviously it comes with it, it's got its own wall wart. So we'll get all these pieces, like I said, set up, and then we'll do a bigger tour through it. So the rest of the stuff in the box is repeats for the most part, with the exception of this guy. Well, let me make sure this is the right one that I'm looking for here. Nope, I was wrong. There's two more things. So this is a power supply unit. Basically, if you don't want to parasitically jump from device to device to device with your low voltage cable, or you're just not in a position where you can basically plug this in independently with its own 110 volt plug, and it's just basically a big power supply. So barrel plug, and then a whole bunch of takeoffs that allow you to power individual devices. So if you're out in the middle of the shop and you had a bunch of tools in the middle of the shop, and you didn't want a daisy chain wire all the way up and around and down to the middle of the shop, you could hang this in the middle and then just run the power out to those individual devices, kind of as needed. The one other device that's in here that I'm super excited about, and I guess I can just pull these out. There's a bunch of 120 volt triggers, and obviously a bunch of actuators. Some more switches, manual switches. Actuator. Switch, 120 volt switch, 120 volt switch. This guy. Okay, so this is pretty cool. A lot of shops, when we're talking about dust collection, also use an air cleaner. A lot of folks have that kind of standard when box style air cleaner. And what this does is this, again, plugs in line to that air cleaner, and then it has infrared and let's see, their infrared and their radio frequency transmitters, so that when the device senses a change in particulate in the air, it will signal the air cleaner to turn on. And all of this being a smart system and running through the hub, there's a whole user integration, a whole UI package that lets you set a bunch of parameters so you can tell devices when the dust collector turns on and then turns back off, how long do you want to keep it running to clear out the lines. You can set the parameters for how much particulate needs to be in the air to turn on and then subsequently turn off your air cleaner. So an air cleaner is a really important part overall of a dust control system within a shop. Mine makes a huge difference in my small shop, and it's nice to have remote control that you can turn on, let it run for 4 hours, walk out of the shop, and it'll continue to clean the air for you. But this is going to be really neat, because not only is it going to allow that air cleaner to function as a standalone, but it's going to integrate it into the overall cleanliness of the shop by sensing how much particulate's in the air, turning itself on, and then when the particulate gets low enough, turning itself off. So I'm really intrigued by this piece, and I'm really looking forward to integrating it into my shop as well. So I believe that's it. There's a little bit of paperwork in here, and there's a toolkit with some screwdrivers, and this is the drill and template for drilling out the handles on the blast gates to allow the actuators to fit on there. Here's additional quick disconnect, low voltage plugs to allow everything to operate together. And then somewhere separately is a large spool of solid core wire for low voltage for running the power. So it's a pretty complete deal. I'm excited about it. I can't wait to actually set it up and get it running. There's a process, obviously, because it's basically smart technology. There's a process to get it all set up and talking to each other, and I'll have to work through that as well. But yeah, I'm excited to get going with it, and there'll be another video following up when I get to that point. So those are all the parts and pieces unpacked. There's quite a bit of it. There's going to be lots of work here to do. I'm excited to get started on it. Some initial impressions of just looking at the parts and pieces as they're coming out of the wrapper. A lot of these are 3D printed parts. They look to be of good quality. For any of you who work with 3D printers, the infill looks to be quite significant. They're sizable. They don't flex a whole lot. They have a nice smooth finish to them. The overall build looks good. They're designed, as I said, the actuators are designed to fit on different size blast gates. They kind of have a universalizing effect in the way they're built. It's really pretty ingenious. I'm looking forward to setting them up. And they can be switched between 2.5 or 4-inch or 6-inch blast gates just by changing the arm that's mounted on it. So it's well thought out. It's intelligent stuff. I've spent a little bit of time talking and texting back and forth with Joel from Grid Automation, and I'm really looking forward to putting this stuff together and getting it working. The user integration, the way it all works together, how it's powered, how you set it up, the granular nature of control that you get from it, the ability to have basically any device tell other devices what to do and have them all work in concert is really a neat idea. Um, I think that it's one of those things that has been done mechanically for a long time in in wood shops, and I'm looking forward to seeing how technology is added to it and what's going to come of it. I really think that this is kind of the next step forward in building out my shop for better, safer conditions. Dust collection is one of those things that has to be taken seriously. It's a health issue, bar none. I mean, that's been very well proven that it doesn't take a whole lot of fine dust to get into your lungs before you really start getting impacted and have longer term problems. And it's just a cleanliness thing, you know. A clean shop is a functional shop, and not that our shop is always clean, but um, the ability to lessen the amount of time it takes you to clean up after a day of work is always a pleasant thing. So it's been a big step forward. This adding the Oneida Supercell and the new ducting, and now the automation piece is has been a big step forward for me. I won't lie to you; it's not terribly cheap, but I look at it from the standpoint of I have some fairly expensive tools in here. You know, a few $1,000 for a tool is really not that much when you look at some of the stuff that's out there. So if you're spending that much on your dust collection system, and your dust collection system makes your tools work better and it makes your whole shop more efficient, it's just another tool that's added to the shop. And any way that you can make your shop more efficient makes you more productive. And if you're a hobbyist like myself that's, you know, not trying to do production work, then it makes it more enjoyable, and that's important. And for somebody who is doing production work, efficiency equates to dollars, right? So less time cleaning up means more time actually working. And if you can be more efficient in moving from machine to machine and having the machines be able to open and close their own dust or their own blast gates to the dust extractor, even better. And lastly, you know, I'm like I said, I'm really excited about the air filtration automation. I think that that's one of those things. I'm pretty good about turning on my air filter. I don't always do it, but I could honestly not tell you how much particulate's in the air here on a given day, good day, bad day, working day, not. So, and that's the stuff, that fine stuff that's floating around is really the stuff that they've shown medically causes harm to your lungs. So hopefully automating that is going to be a benefit that I'll get to enjoy as well. So this video is longer than I intended it to be, I guess, because I'm not very good at unboxing videos. That's what happens. But I hope that you'll come back and watch the next couple videos that I'm planning once I get stuff up and running, and do more of a tour of it and talk about the specifics of the equipment as I see it and how I'm using it and what I'm doing with it and what my thoughts are on setup and my thoughts are on the integration. So thanks. Stay safe in your shop. Enjoy, and I'll talk to you again soon.